Hey buddies, my name is Sibusi Somtiniso, but I'm also known as Coach Sbu. Welcome into the Mathsbuddies tutorials. In today's video, I'm going to be showing you how to prove a sine rule using an obtuse-angled triangle and an acute-angled triangle. So without wasting any further time, let's start off with our obtuse-angled triangle. So the first thing I'm going to do here is I want to first name this triangle ABC, okay, like that. So now what is the first step that you need to do when you're proving a sine rule in this type of a triangle, or this triangle we call it an obtuse angle triangle. Now the first thing that you must always do is to construct a right angle triangle. Now the reason why for that is because when I use sine theta, cos theta, and tan theta, and also when I'm able to use Pythagoras, right? Because now at the moment right now, this is not an angle, this is not a triangle that is an angle of 90, so it means we are not allowed to do that, right? And then whenever you're creating a formula, we must always use something that you already know. Hence now, what we're going to do here, we're going to construct a right angle triangle like that. So notice that I drew this perpendicular height from that top to this part, and then make sure that it connects with that base. Then out here, I'm going to call this part height H, and then this side I'll call it D. Already it's going to be A, B, C, D, and then this side now I'm going to call it X. Okay, then now after this, now already I know that this is angle A, so which means this side it is side A. This is angle B, which means this is side B. This is angle C, and then this is side C. All right. Now, after I have found these angles, right, what's the next thing that I need to do? Now, the next thing that I need to do here is I need to only take the angles or the triangles that are right angle triangles, right? Now, in this case here, I'm going to write them here. The first triangle, that is a right angle triangle, because those are the ones that are going to help me here. It is going to be triangle ADB, which is the one that I've constructed. Then the second one here, it is going to be triangle ADC. Okay, now that I have found these sides, what is it that I need to prove here? Here, what we are required to prove, I'm going to write it here because it is very important for you to know the hint for this. Now here, what we are required to prove here, it is a sine rule, right? Now, because of it is a sine rule, it means now what I need to do here is I need to look at this unknown h and then calculate it using the trig ratio of sine, right? Now, in order for me to do that, I will use this part here as my angle, right? As my angle reference, and then from there, I'll calculate what is sine of this angle, right? Now, in order for me to get this angle, I must also acknowledge the fact that this angle here, it is angle B, right? So this is angle B, so I'm just gonna write it here as a head. So this means now if this is angle B, then this one surely is going to be angle 180 minus angle B, right? Because I know that the sum of an angle, or the sum of angles in a straight line, they add up to 180. So it means in order for me to get this angle, I need to take 180 and subtract angle B. So which means this angle here, it is 180 minus angle B. All right. So now, to answer that question here, therefore, in triangle ADB, if I want to calculate this unknown h, because I need to know this h here, I'm going to say sine of 180 minus angle B. It is going to be the opposite, which is in this case is going to be h over the hypotenuse. So the hypotenuse for triangle ADB is going to be side C, right? So from here, I then see that 180 minus B is a reduction. So which means now here, sine is positive in the second quadrant. So which means this is going to be sine B, which will also be equals to h over C. Then from here, I will then cross multiply this C to the other side. Then it means C sine B is going to be equals to h. So which means now here I have calculated my h. Now, after I've calculated my h, I'm going to ask myself what is the other way, or what's another way that I would have done to calculate h. Now, another way that I would have done to calculate h was if I had to look in triangle ADC, right? Now, by looking to triangle ADC, which means I have this angle C, and this is going to be the opposite again, but then B is going to be my hypotenuse, right? So it means now I'm going to say sine C is going to be the opposite, which is H, over the hypotenuse, which is B, right? And from here, do the same thing. I cross multiply this to that side, and then now here B sine C will be equals to H. Now notice here that I've found two ways to calculate H, right? Now because of I've found two ways to calculate H, it means now it doesn't matter which part that I'm using here, H will be the same value, right? So what does this mean then? So this means now if I'm saying H is C sine B and also H is B sine C, then therefore C sine B will then be equal to B sine C. Why? Because they both represent H. And then from here, what I'm going to do here now is I'm going to then divide both sides, right, by BC, right, by BC, and also this side by BC. Why am I using B and C? It's because I know if I use B and C, this C will cancel with that, and then this B will cancel with that. And now what is it that I have left? And then from here, I can see that what's left here is going to be sine B over B, which will be equals to sine C over C. And that is how I find my proof using the obtuse angle triangle. Now let's go ahead and try and see how do we then do it when it comes to an acute angle triangle. Now when it comes to an acute angle triangle, because of all the angles are inside here, we can easily spot a perpendicular height here. But then now the first thing again, like we did in the previous question, I'm gonna first make sure that I label this triangle, right? So let me use S I N, right? So I'm gonna call it triangle sine, right? Then now from here, I'll then create perpendicular height inside here, like that, and then I'm gonna give it H again, right? Now here, the tricky part about this one is this. Now here, we know that this whole side here is side S, right? And then this side it is N, and then this side it is I, right? So now if I create my perpendicular height, right, it means now when I have something new here, I'll have one of these sides as X, right? And then the other side will then be X minus S, right? So which means now here I'll then call this side X, and then this part here I'll call it S minus X. Now why S minus X? Because here the whole part is X, and then this small portion here is X. Then this then means that the remaining part, let me use a different color rather. It means the remaining part here, in order for me to get it, I need to take the bigger part, which is S, and then subtract the smaller part, which is X. All right, and now here we're gonna basically do the same thing. So here we want to calculate what is H. Now to find H, I can either use this side, and then this is going to be opposite over hypotenuse, right? And then over this side, which will then be opposite over hypotenuse, right? So let's go ahead and do that. So it means now here, which triangles am I looking into? So here I need to name the last side here. I forgot to mention that. Now this side here, remember we created our perpendicular height. So now here I'll just give this E so that it becomes sine, right? Okay, so now which means now in this case here I have two triangles. I have triangle S I E and triangle S and E. Okay, now in triangle SIE, therefore in triangle SIE, I see here that sine I will be opposite, which is h, over hypotenuse, which is going to be n. And then what we do again, we cross multiply here, then this give you n sine I equals to h, right? And we do the second part in triangle S and E, sine n will be equals to the opposite over the hypotenuse I. And then when you cross multiply again, you're gonna get I sine n equals to h. And then from here again, what we notice here, we see that h is represented in two ways, so therefore we're going to take one way. So you're going to say therefore I sine n can be the same as, or is the same as, n sine I. And then from here we divide by the values or the alphabets that are next to the trig ratios. In this part it is I, that part it is n, so I'm going to write it as I times n, and then same applies here, it will be I times n. Now by doing that, then this means this cancels with that and this cancels with that, and then what we have left, which means now here we're going to be left with sine n over small n equals to sine I over small I. And that is how we prove this sine rule formula. And that's it for this video. If you like the video, please make sure that you leave that in a comment below. Please share it with your friends, because this they might find it very helpful. And in our next video, we're going to be going through how to solve a cosine rule using the same type of triangles, which is an obtuse-angled triangle and an acute-angled triangle. And I'm going to see you on to the next video. Cheers.